Welcome to the Bourns ESD Protection Product Training Module. This training module provides an in-depth look at Bourns circuit protection products that help provide protection for sensitive electronics against ESD, EFT, and power surge threats. Also included in this product training module are different protection schemes for a wide variety of applications. At the end of the module, there is a flowchart to help you select the right product for your application. Bourns offers 3 different technologies in its line of ESD protection products. 1. Transient voltage suppressor diodes utilizing avalanche breakdown of the silicon diode in discrete or array configurations. 2. ESD suppressor products using multi-layer varistor technology with options of discrete or array configurations. And 3. TVS steering diodes which implement a rail-to-rail clamp technique in either discrete or array configurations for ESD protection requirements. ESD protection products are necessary to protect against ESD transients entering the system or device, which will damage or destroy the electronics. The end applications for ESD protection products are broad, ranging from telecom, consumer, low to medium risk medical, industrial, and computing. Since every electronic human interface port or connector is considered a possible entrance for ESD transients into the downstream circuitry of a system or device, the demand for ESD protection devices will be huge. On the back of a typical set-top box shown here, the wide variety of interface ports that will require ESD protection products can be seen. For these USB, Ethernet, and HDMI ports, ESD protection is required to limit product damage and increase the robustness of the equipment. Human body ESD voltages can be 15 kV or more, which will damage the IC. The key to selecting overvoltage protection is to consider what the equipment needs to be protected against. Therefore, it's common practice to protect all people interactive data ports to limit product damage and increase the robustness of the equipment. The external ESD protector then becomes the first level of protection, with the IC providing residual second-level protection in the design. The International Electrotechnical Commission, or IEC, developed a human body model, HBM, ESD event that would allow designers to design adequate protection into their electrostatic applications. The IEC defined the ESD discharge impulse with a rise time of less than 1 nanosecond and decay time of 60 nanoseconds designated 4 levels of protection. IEC 61000-4-2 specifies HBMs up to 8 kV contact for ESD incursions that would be considered in portable equipment. The protection embedded in the IC is not robust enough, hence external protection is necessary. It's therefore important to ensure that the circuit used to protect the IC can support this peak voltage of 8 kV. The most common method for ESD protection is to use small silicon-based transient voltage suppressor, or TVS, diodes in avalanche breakdown mode as the first level of protection against ESD. A wide range of working peak operating voltages are available in unidirectional or bidirectional configurations arranged in discrete or array packages. TVS diodes provide ESD protection per IEC 61000-4-2, while their enhanced construction can provide additional electrical fast transient (EFT) and surge protection to the IEC 61000-4-4 and IEC 61000-4-5 standards, respectively. Bourns offers ChipGuard ESD suppressor products using ceramic technology as an alternative ESD protection solution. The ChipGuard ESD suppressor has a threshold voltage where the initial resistance is high, 120 megaohms for Bourns CG0603 MLC family. As the voltage increases, the resistance decreases with a resultant exponential increase in the current through the device. This allows the overvoltage disturbance to be shunted away from the protected circuit, while the energy is dissipated in the protector. Once the electrical disturbance has passed, the ESD suppressor will return to its high-resistance off state. The technology provides an ultra-low capacitance of 0.05 picofarad maximum rating, which makes them very attractive for high-speed applications. Some designers prefer to use a rail-to-rail clamping technique for ESD protection, and Bourns can satisfy this scheme with discrete or array steering diode solutions. Using the VCC line as positive and the ground or VDD line as negative, ESD transients on data lines can be diverted to either the positive or negative rail. A range of steering diodes are available in discrete and array SMT packages that would be ideal for this application. The USB Universal Serial Bus specification provides a platform to allow a single USB port to drive up to 127 USB peripherals from a single host termination, PC. USB also allows remote powering from a broad range of low-power aftermarket accessories, including travel lights, mobile phone chargers, and laptop backup hard drives not requiring their own power supplies. USB 1.1 provided data transfer rates of up to 12 megabytes per second, while USB 2.0 provides for data transfer rates of up to 480 megabytes per second. In a USB 2.0 application, the overvoltage protection can be provided using a 5-volt low-capacitance TVS diode, such as the model CDS OD323-T05C. Or a 0.5 picofarad ESD suppressor such as the model CG0603MLC-05LE. Alternatively, the use of a steering diode array with the model CDSOT23-SR208 is another possible solution using a rail-to-rail clamp technique to the VCC rail and ground. To meet the USB 2.0 overcurrent protection requirement for self-powered hubs and hosts, the use of a Bourns multi-fuse PPTC resettable fuse, such as the model MF-NSM L150/6, would be an ideal solution. In this example, when the PPTC resettable fuse trips on overcurrent, it removes or reduces the current to all the affected downstream facing ports. For applications that provide 2 times USB ports, the model CDSC706-0504C device uses integrated technology, which can provide a more cost-effective manufacturing solution. The latest USB 3.0 standard was released in November 2008. A higher speed transfer rate of 5 gigabytes per second and higher 900 milliamp current limiter on VBus are specified. The USB 3.0 standard requires 4 additional data lines. The super speed of 5 gigabytes per second will still require ESD protection solutions, but with a lower capacitance rating. Shown here are Bourns circuit protection products that will meet the USB 3.0 standard. For applications that provide 2 times USB 3.0 ports, the model CDSOT236-0504LC device uses integrated technology which can provide a more cost-effective manufacturing solution. The ESD and overcurrent protection scheme using model MF-NSM L200/6 and model CDD-FN10-0516P for USB 3.1 is shown here. The high-definition multimedia interface, or HDMI, provides for transmitting digital television audiovisual signals from DVD players, set-top boxes, and other audiovisual sources to television sets, projectors, and other video displays. HDMI can carry high-quality multi-channel audio data and can carry all standard and high-definition consumer electronics video formats. It can also carry control and status information in both directions. The HDMI connector has a pin that allows the source to supply 5 volts and a 55 milliamp minimum to the cable and sink. With high-speed communication on the 8 data lines, ESD protection with ultra-low capacitance is required. ESD protection solutions can include a discrete package option using the ChipGuard model CG0603MLU-05E device with a maximum capacitance of 0.05 picofarads, or alternatively array solution shown here using the model CDM-SP10-0504M and CDSOT236-0504LC devices, making them ideal for meeting the requirements. The ESD protection scheme shown above uses integrated diode solutions with 2x model CDD FN10-3324P and a CDSOT236-0504LC having ultra-low capacitance values, less than 0.65 picofarad, making high-speed data transmission possible. TVS diodes are also considered in secondary ESD protection schemes. It's important to determine the energy transfer across the windings so that a TVS diode can be suitably selected for the application. A TVS diode reference voltage will increase as current flow through it increases. Here, a 3.3-volt TVS diode array solution uses the model CDD FN10-3304NA device in a small DFN10 package is shown on a high-speed gigabit Ethernet port. Here, another surge and ESD protection scheme for gigabit Ethernet protection is shown. A 2.5V TVS diode array solution using the CDD FN10-2574N device in a small DFN10 package provide adequate protection against surge and ESD while having minimal effect on the data transmission rates due to the low capacitance of the TVS diode. The protection scheme shown here, though similar to the one on the earlier slide, makes use of 4x model TBU-DT085-200-WH, dual unidirectional transient blocking units, the TBU-HSP, short for high-speed protector. A TBU-HSP provides protection against current surges. This device uses innovative MOSFET technology and provides protection in less than 1 microsecond by going into high impedance state, thereby limiting current and consequently protecting the electronics downstream. TBU-HSPs also have automatic reset capability. Ethernet power solutions such as Power over Ethernet and Power over Ethernet Plus are being developed. Bourns has circuit protection products available to meet these requirements, which are shown here. In this ESD product selection flowchart, the best product can be chosen based on criteria such as ESD protection versus ESD plus surge protection, capacitance value, and discrete versus array packages. Just follow the flowchart to determine the best choice for the application. The Bourns website, www.bourns.com, shows the latest product offering and provides several resources to aid in the design and evaluation of ESD protection applications. In summary, Bourns ESD protection products provide new high-density integrated passive and active component technology with significant benefits such as cost reduction and enhanced performance for any application.